For this activity 4, we are going to talk about the OR gate. We are here to demonstrate and simulate the basic function of the OR gate and its application. The OR integrated circuit is the simplest digital logic gates in terms of its function. This gate simply outputs a high signal 1 when at least one input is high or 1. The symbol of the gate is like a triangle but with curved edges that looks like a sharp fin. The input side is from the bottom concave side and the output side is from the tip. The truth table for the AND gate is very easy compared to the other gates. When any input has a 1, the output is automatically 1. If it does not have any 1 input, its output is automatically 0. It basically outputs 1 when there is any 1 input present. Next is the 74LS32 integrated circuit. With its 14 terminals, one terminal is for the power input and at the opposite end is the ground terminal. The remaining 12 terminals make up the 4 gates having 3 terminals each, 2 for the inputs and 1 for the output. Shown here is a diagram of this integrated circuit. Our goal for this activity is to figure out what is the outcome for this LED and LS32 configuration. Analytically, we can try to figure out the output of each LED with its corresponding inputs. For L1, L2, and L3, their corresponding switches must just be on for it to be on. At L4, it takes input from gate A with inputs from D0 and D1. So if any of these switches is on or any of L1 or L2 is on, L4 is automatically on. For L5, it takes input from gate B, which takes both inputs from gate A. In this configuration, it would have the same output always from L4 since it has the same input, which is the output from gate A. Lastly, for L6, it takes input from gate D, which takes input from gate C and D2. Now, gate C takes input from D0 and D1. This would mean that gate D takes output from all the switches. Thus, if any of the switches were on, L6 is automatically on. Here is the truth table of the significant changes of its respective input combinations. So, let's start! The materials needed for this activity are breadboard, jumper wires, 3 push buttons, a power supply, 6 pieces of 3.9 kΩ resistors, 6 pieces of red LEDs, and most importantly, the 74LS32 integrated circuit. Before we start with the hands-on proper, we can simulate the configuration using Tinkercad for easier building of the hands-on circuit. After multiple troubleshooting, we now have the working circuit which coincides with our analytical solution. Before we begin, let's check if the components are working. Now we can start.
Saw you in the red dress. I can't seem to understand how you got all that finesse. Still been running in circles inside.
As you can see, the output of our hands-on circuit coincides with our Tinkercad simulation and also coincides with our analytical analysis from before. In this activity, we demonstrated the operation of the OR gate using the 74LS32 integrated circuit. The OR gate output was high when at least one of the inputs was high, consistent with the truth table. OR gates play an essential role in digital electronics, particularly in decision-making circuits where multiple conditions needs to be evaluated. Further exploration can involve combining OR gates with other gates to develop more complex logic systems. I hope you learned something. Thank you for watching.